welding. What are they? So you will have fusion zone, you will have heat affected zone, we call it as heat affected zone. Uh, so it will be unmelted zone around that fusion zone, and there will be a part which is completely unaffected, or the we call it unaffected original part, right? So those are my three distinct regions of any kind of welding structure. Unaffected, unaffected, let's say base metal. Of course, this is base metal. Now, the most important factors that governs a fusion welding, what are they? They are the characteristic of heat source. So you will have characteristics of heat source. Then you will have uh, the nature of the deposition of the filler metal, nature of deposition. So these are my governing factors through which you can understand how is your welding happening, right? Then you will have heat flow characteristics. So lot of physics happening over there. People regularly do those finite element analysis to understand what will be a temperature distribution in your weld structure, what will be a temperature distribution in the heat affected zone. So because of depending on your material property, your what will be your heat flux input, depending on those things your temperature will vary, and ultimately those temperatures will affect your metallurgical structure, right? It will affect your um, ductility or brittleness of your structure. So those things all are interconnected. Um, then you will have those chemical reactions. So let's say maybe slag metal reactions or gas metal reactions. Those things also uh, will affect your welding structure. Then finally the cooling rate. Cooling rate is a very important factor over here for your welding process, right? So those things are there for fusion welding. Now, what is there for solid state welding? So I'm coming later for these questions. Don't be confused. So initially, I'm trying to cover the things which you have already gone through your earlier lecture videos. Those things I'm trying to cover, and then we'll come to those question and answer so that it will take very less amount of time to answer those things because those are MCQ parts. है ना? So that's how we proceed each and every week. Okay. Now, what is there in solid state welding? So in solid state, uh, when two metal surfaces are brought into contact, uh, so basically the real contact takes place through a small area of asperities, right? Because of surface roughness. So you will not have a complete area of contact. You will have some kind of small area of asperities where those real contact is taking place, right? So your real contact area will always be less than the theoretical contact area which you are calculating. You know? Now, this metallic bridging occurs even in the presence of some adsorbed surface layers of those I was mentioning, no? Those oxide contaminants. Now, the bridges so formed have the property of are you familiar with this grain boundary? I'm mentioning this again and again. Anyhow, uh, grains. Anyone familiar with this term, grain boundary? Yes or no? Can I have an answer on yes or no? Please try to respond. uh, unless it will be very difficult for me to understand you guys are something getting into or not. It could be that in this meantime it will be above of your head, but yeah, try to absorb things. And anyhow, we are recording things and we will recap things again after this live session is over. So, anyone is familiar with grain boundary? So, if you have a material and if you do some chemical treatment in material, so any kind of material, it can be aluminum, it can be copper, it can be steel. If you do some chemical treatment, or we call it etching, you do some chemical etching, you will see that those materials are consist of some structures, small structures like this. We call it grains, like this. So grains are very important factor to what should I say? Um, to give you the clue of why your structure is uh, why your structure is having a better strength or better ductility or lower strength or lower ductility. So grains can give you a very good picture, right? In terms of understanding things metallurgically. So the boundaries over here of two different grains. So for these two different grains, if you are thinking of uh, in atomic scale, the atoms will be arranged in different directions for different grains. So wherever those different directions of atoms meet, it will create that boundary over there. So that is called grain boundary. So as I was mentioning that those bridges, those small area of asperities, they create those bridges, and they have the property of those true grain boundary, and hence they are stronger than the bulk material actually. Now, yeah, there can be some kind of work hardening and those things, plasticity. So there can be some kind of work hardening and plasticity is there because of deformation. So plasticity, I'm mentioning just the terms. Strain hardening happening. I don't know if you have heard the term called recrystallization. Then you have heard the term recovery. So those things are happening whenever you are doing something called severe plastic deformation. Okay. So in any kind of solid state welding, you have to have deformed the material. So if it is friction stir welding, through stirring the tool over this, maybe we will cover in upcoming lectures. So if this is solid state welding, you can let's say this is ultrasonic welding. There will be having some tool or horn kind of thing which will vibrate over the surface and which will deform the material. And because of material deformation, the metal atoms will diffuse into one another in solid state. Uh, so this is basically kind of forceful diffusion. I would mention that. So forceful solid, forceful solid state diffusion in solid state welding. Right now, let me mention also those four different terms for solid state. So you will have surface deformation, you will have um, recrystallization, and you can have interdiffusion. Interdiffusion means diffusion of two different metal atoms into one another, right? Yeah. So let me have some water. Till now, any question? You can
You
ask
can
me if
ask
there
me
is
if
any
there is any
question.
question. No, sir.
No? Are you getting things, or is it a little bit getting tricky to absorb? Is there any suggestion? Okay. So, yeah. So we have talked about different kinds of welding. We will have some detailed discussion on different welding, different mechanisms of welding of this arc, arc welding, gas welding, and whatever is there in terms of solid state welding also. So the classifications, as I was mentioning, they could be on different aspects, right? They can be from depending upon the source of it. They can be on depending on the application of pressure. They can be on different phases of base and filler materials. They could be composition of the joint, position of the electrode, and the mechanism, of course, is there. You know? Now, in pressure welding, you will have two different kinds of things. So, uh, you are using pressure, external pressure for the solid state welding, and for fusion welding, you are not using any kind of external pressure. You just uh, hitting the material to a molten state and allowing the diffusion to happen for time, and then you are basically giving some cooling period or solidifying the material. So because of melting and solidification, the joining is happening over there. Correct? Now, yeah. I have talked about this soldering and brazing. I have talked about this friction welding. Then you have ultrasonic diffusion. There are also something called forge welding. You can have roll welding. We have talked about this autogeneous welding, homogeneous welding, heterogeneous welding. So this we have talked till now, right? So as you don't have no questions till now, so we will move to the types of welding depending on the positions of the welding also, right? So in terms of position of welding, what are there? Can anybody give some name on different types of welding corresponding to the position of welding? What are there in terms of position? Let me draw a figure.